Hello friends, welcome to Susan and John MathTube. This is lesson number 22 in the examination preparation series for first year engineering students. And we are still on differentiation under the integral sign. That is Leibniz rule for integration. In lesson number 20, you learned how to do partial differentiation. And in lesson number 21, we learned how to apply Leibniz rule and integrate. And now in this video, we are going to learn a few more important problems which can be done with Leibniz rule. So as always, let's start with the most important question. So point number 1, 2, 3, 4 and 5. And I hope you're following all these things. So let's start. Be ready with pen, paper, everything. So let's start. So write the first question. Evaluate the integral. So please write evaluate the integral. I is equal to integral 0 to infinity. Tell me please, what do you call this integral? Improper integral. Okay. Anyway, I'm not bothered about that part right now. I have a function, the whole divided by x into e power minus x dx. Okay, so the first thing, the variable of integration is x and the parameter in the integral is a. So when we apply Leibniz rule and when we differentiate, we will be performing partial differentiation with respect to a. So as always, you can write the first line, differentiating both sides with respect to a using Leibniz rule. So what happens is I get di by dA. And remember, solving this integral or evaluating this integral means evaluating I. Okay, so we're going to differentiate the integral that goes inside and it becomes partial differentiation. Wait a minute, I think it will be good for you if I write or rewrite the integral in this format. So I'm going to write e power minus x by x times 1 minus e to the power minus ax dx. It will be better if I write like this so that differentiation becomes easier. Now look at this. We are going to perform partial differentiation. And we are going to perform partial differentiation with respect to a. So this part, clearly this part is a constant. So we write e power minus x by x as such. And we differentiate this part with respect to a. So the derivative of 1 is 0 and I put negative and then we get e to the power minus ax times minus x because a is the variable and x is the constant when we perform partial differentiation with respect to a. So remember, a is our variable right now, so we get this. And if you don't understand this, I will recommend you to watch lesson number 20. That's it. Now you can simplify a little bit. Minus minus will be positive. X and x will get cancelled. And we get di by dA is equal to integral 0 to infinity e power minus ax into e power minus x dx. Isn't it? This will be positive. So the only terms which remain will be this. Okay. Now something simple. What is a power m times a power n? A to the power m plus n. So we end up with di by dA is equal to integral 0 to infinity e to the power, you can combine it, you can add this, minus ax plus minus x dx. And now this minus will come common, so we get di by dA is equal to integral 0 to infinity e to the power minus a plus 1 into x dx. Wait a minute, I gave you a promise. I gave you one guarantee in the last video, and the promise was very simple. If you perform Leibniz's rule, if you do that partial differentiation and simplify a little bit, look, I simplified, and I finally got this. My guarantee is you will be able to integrate now. So we are ready for integration. But before we integrate, I have to ask one question which might benefit some of you. What is integral e to the power ax dx? It is e to the power ax, the whole divided by a plus c. So what will be integral e to the power minus a plus 1 x dx? That will be e to the power minus a plus 1 x, the whole divided by minus of a plus 1 plus c. And another important thing which I always do when I teach exponential function is the graph of the exponential function. Nowadays this is very famous because of the coronavirus number of deaths and the number of cases, because that's also in the exponential model. So every exponential function will cut through 1, because e to the power 0 is 1, a to the power 0 is 1, 2 to the power 0 is 1. And then what happens is it shoots up. It shoots up, and we call this the hockey stick model. Now it looks like a hockey stick. What happens is the height of the graph keeps on increasing. So e power infinity tends to infinity. At the same time, e to the power 0 is 1, and here the graph becomes asymptotic. That means e power minus infinity tends to 0. So you need all these facts before we start integration. Okay, now the most important question. What is this integral? Okay, it's an improper integral. In your exam, you have to write like this on one side. Improper integral. And I think you're familiar with improper integrals. If not, you can watch the videos related to improper integrals. So we get limit t tends to infinity, 0 to t, e to the power minus a plus 1 into x dx. So this is how we deal with improper integrals. In exam, you can write improper integral type 1. I think you remember type 1, type 2 simple, type 2 special. There are 3 types of improper integrals in your syllabus. Type 1, type 2 simple, and type 2 special. Okay. And now we are ready for integration. I already gave you all the base for integration. So we end up with di by dA is equal to e to the power minus a plus 1, the whole divided by minus a plus 1, limit t tends to infinity, x varies from, I always love to make it very clear, so x varies from 0 to t. Minus a plus 1 in the denominator is a constant, so I get di by dA is equal to minus 1 by a plus 1, limit t tends to infinity. Okay, it's time to plug in those values, but if you want, I'll write one more step that might make things more clear, where x varies from 0 to t. That's exactly the integral. Okay, now time to plug in values for x. So first I'm going to plug in x is equal to t, the upper limit, then I will plug in x equal to 0. So we get di by dA is equal to minus 1 by a plus 1. Limit t tends to infinity. We get e to the power minus a plus 1 times t minus e power 0. E power 0 is 1. I already showed you that hockey stick graph. It's very easy to understand the values from the hockey stick. So e power 0 is 1 and e power infinity is infinity and e power minus infinity is 0. Okay, now you plug in infinity instead of t. So you get di by dA is equal to minus 1 by a plus 1. So look at this, when we plug in this over here, we get e power minus infinity. And that is 0. So you get 0 minus 1. So as I promised, you were able to integrate. And the value of the integral is 1 by a plus 1. Now the big question. What are you trying to find? And the answer is, we are trying to find the value of I. Okay, but what did you find? Di by dA. So no need to worry. So just use variable separable technique from differential equation. Make it a differential equation. Integrate and you get I is equal to be honest, I tried natural logarithm, but I'm just following the books which is in your syllabus. So we can write log a plus 1 plus c. So for 1 minute we were really happy, but this answer is not satisfactory. Think about it. Why are we not satisfied with the answer? Because the given integral I is a definite integral, and a definite integral will never have arbitrary constant in its answer. So the technique is very simple. Call it equation 1. And now you draw a box, and inside the box the first thing to write is the question. So our question goes 1 minus e power minus ax, the whole divided by x times e power minus x dx. And then you turn back and check. Okay, we had been differentiating with respect to the parameter a. So I write, putting a is equal to dash gives I is equal to 0. So I want this integral to vanish. I want you to select a value for a in such a way that this integral will vanish. Can you give me that value? Is it 0? Is it infinity? Yeah, it's 0. Because e power 0 will be 1. 1 minus 1 is 0. The numerator is 0. That's the end. Okay. Now we will plug in these special values or the particular values and find c from equation 1. So I plug in I equal to 0, a equal to 0 plus c, and that gives me, because log 1 is 0, I get c equal to 0. Finally, you can be very happy because by equation 1 we get I is equal to log a plus 1 plus 0. That's it. That's the end. Okay, now let's try something similar, and that will be the last problem in today's video. So please write the question. Evaluate the integral 0 to infinity e to the power minus ax minus e to the power minus bx, the whole divided by x dx. First things first, never forget to give the name capital I. So let I be the given integral. Evaluating this integral means finding the value of I. So we are after I, we are trying to find the value of I. Now the variable of integration is x and the parameters are a and b. That gives me an option. I can differentiate with respect to a or b. It looks kind of like symmetric, so doesn't make much difference. We will get the same answer. Okay, anyway, for uniformity's sake, right now I'm sure that you are working out the problem along with me. So let's do it together. So let's differentiate with respect to a itself. And remember, Leibniz allowed us to differentiate an integral. But when we do that differentiation, you should be performing partial differentiation with respect to the parameter. And that tells me a is the only variable. A will be the only variable in this particular step. So the denominator is a constant. The second term is a constant. So we get e to the power minus ax times minus x minus 0 dx. If you did not understand this step, I will strongly recommend pause the video right now and take lesson number 20, learn partial differentiation properly and come back. Now we simplify, so we get di by dA is equal to, there will be negative x and x will get cancelled, so we get negative integral 0 to infinity e to the power minus ax dx. Okay, and in bracket, what should I write? Did you notice something wrong with the integral? Yeah, improper integral. Is it type 1 or type 2? Of course, type 1. We have to deal with this improper integral. So what I do is I change the integral into a limiting problem. So we get integral 0 to t e to the power minus ax dx. That will be our di by dA. And on one side, again I am going to ask a question because my promise was, once you apply Leibniz rule, I guaranteed you will be able to integrate. Okay, so I am going to ask the question, what is integral e power ax dx? And one very important thing, these videos are made for weak students and average students. And that's why I'm moving really slowly. And I personally know a lot of students who are doing their back exams with the help of these videos, because some of the students always ask me why I'm teaching so slowly. The reason is I want all my students to understand the material. Okay, so that's the main reason I keep on repeating such important steps. It may be silly for some, but it may be very important for the weak students. Yeah, okay. So what is integral e power ax? It is e to the power ax, the whole divided by a plus c. So now we will be able to integrate. So we get di by dA is equal to limit t tends to infinity e to the power minus ax, the whole divided by minus a, within the limits x equal to 0 to t. And by the way, there is a negative outside. I think we didn't write that negative here. Di by dA is equal to, this is a constant, so we get 1 by a, and the remaining part limit t tends to infinity e power minus ax, x equal to 0 to t, and that gives me di by dA is equal to 1 by a. Now I'll plug in the upper limit and lower limit, so I get e to the power minus 80 minus e to the power 0. E to the power 0 is 1. Okay, I'll strongly recommend draw the hockey stick, and the values are obvious. E to the power minus infinity tends to 0. E to the power 0 is 1, and e to the power infinity, look, the height of the graph goes like anything, and that gives me infinity. Anyway, you plug in all those values. Finally, I kept my guarantee that you will be able to integrate. At this point, we have to ask one question. What exactly are we trying to find? And now you know the answer. We are trying to find I. The second question, what did you find? You didn't find I for sure. You found di by dA. And what we do is we change this into a variable separable problem and integrate, and we get I is equal to minus natural logarithm, but I will write log A plus C. Now call it equation number 1. You cannot be too happy because we have a definite integral and that will never have plus C. So it's box time, and inside the box you write the question. Now tell me, what should I put? What should I put? Wait, I differentiated with respect to A. Instead of A, so that the given integral will vanish. Think about it. What should I write instead of A so that the integral will vanish? Very simple. Put A equal to B. Now let's plug in this thing in equation 1. So look at this. Instead of I will put 0. Instead of A, I will put B. So I get minus log B plus C. And that gives me the value C equal to log B. That's it. Close the box. Now time to write the answer. So I'm going to write therefore by 1, I is equal to minus log A plus log B. That is log B minus log A. So we get I is equal to log B by A. So that's it. I'll be back with a few important questions in the next video. So as always, if you like the video, please share and subscribe. I'll be back soon. So till then, my friends, bye.